Hello everyone, welcome back to this channel. Let's continue intermediate machine learning. As of now, we have understood how to handle missing values, how to handle categorical variables, how to create any pipelines for a project. Okay, now we are going to understand cross validation. This is about measuring the model performance. Okay, first we will read, then we will do the exercise. This is for better measures of model performance. Okay, so you will face choices about what variables to use, what types of model to use, whether linear, whether XGBoost, whether something else, what arguments to supply for, what are the parameters. So far you have made these choices in data driven way by measuring model quality with a validation dataset. You know validation dataset, training dataset and validation dataset. Let's say your data set has total 1000 row points. So you have to keep some portion for training, you have to keep some portion for testing or validating how your model is performing, right? So maybe generally we use 80-20%. So 800 rows will be used for training, 200 rows will be used for testing. Okay. Now, there are some drawbacks. To see, imagine if you have a dataset of 5000 rows, you will typically keep 20%, 1000 rows, but leave some random chance in determining model scores. Maybe that one model is performing good on 1000 rows, but not on another 1000 rows. Let's say, as I have told you, you have applied some model and you have trained your model. Now you are testing on these 200 data points. Now what is happening? This is giving you a good accuracy. So you will think that your model is performing well. But maybe on another 200 rows, not this one, but another 200 rows, this is not performing that well. Okay. So this is contradictory. 200 rows are giving you good performance, but another 200 rows may not give you a good performance. So better approach is you take a bigger validation dataset, right? But what will be the problem with the bigger validation dataset? There will be some problems. You have to take some data points from training to testing, then only you can make the validation dataset bigger, right? But if you take away the data points from training dataset, then on which you are going to do the training? Okay, so there is a problem. If you want to make the validation dataset bigger, you have to take the datasets from the training dataset. And if your datasets are less here, then your model will not be trained properly because you have fixed data points. Okay, now see how we can solve this problem. So at an extreme, you could imagine having one row of data in validation set. If you compare alternative models, which one makes the best prediction on a single data point, that will be a matter of luck. In general, the larger validation data set, the less randomness there is in measuring our model quality. That's what I have said to you, and the more reliable it will be. Unfortunately, we can get only a large validation set by removing rows from our training data. So smaller training data set means worse models because you are not training, actually you have smaller data points to get trained. Okay. So how to solve this problem? The technique is known as cross-validation technique. We run our modeling process on different subsets of data to get multiple measures of model quality. Let's say we could begin the dividing the data into 5 pieces, 20%. So we will get 5 folds. Now first part is used for validation, other parts are used for training. Second part is used for validation, other parts are used for training. Okay, let me show you here. Our dataset has 1000 data points. So what we are doing, instead of keeping 800, 200, we are dividing it by 5 folds. Okay, so every fold has 200 dataset, right? Now, in your first iteration, you are taking these 200 datasets for validation. And these are used for training. Okay. In second iteration, you are used these 200 for validation. And all this one, this one, this one and this one will be used for training, right? In our third set, these 200 are for validation. This is for training, 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 training. In the fourth, for validation. All others will be used for training. So what is happening? In each iteration, you are using 800 rows for training, 200 rows for validation. But in every iteration, the validation rows, the validation data points are different. Okay. So here it was same and training dataset was also same, but we are changing here. The training datasets are also getting, training data points are also getting changed and validation data points also. Okay, this technique is known as cross validation. Now let's read here. In experiment 1, we use the first fold as a validation dataset all others for training. Second experiment, we hold out the second fold and we are using others for training. So we repeat this process using every fold once as a holdout set. Putting this together, 100% of the data is used as holdout at some point, and we end up with a measure of model quality that is based on all of the rows in the dataset, even if we don't use all rows simultaneously. Now, when should you use cross validation? Cross validation gives a more accurate measures of model quality, which is especially important if you are making a lot of modeling decisions. However, it can take longer to run because it estimates multiple models. Exactly, it is estimating different models, so it will be longer to run. Okay. Now, for given these trade-offs, when should you use this approach? For small data sets, when extra computational burden is not a big deal, you should run cross-validation. The computational burden is the problem. So, when that is not the big deal, you can use second. For large data set, a single validation set is sufficient. Your code will run faster. You may have enough data that's there, little need to reuse some of it, hold out. If your data set is larger, what we said before, that we need a bigger validation data set. If it is already larger, then you don't need to do this because this is taking your time, this is taking your memory. Okay. So for larger data sets, you may reject this. For smaller data sets, this may be a very good approach. Okay. But when we call it a large dataset and when we call it a small dataset, there's no simple threshold. It depends. If your model takes a couple minutes or less to run, it's probably worth switching to cross validation. Your decision, your call. Okay. Alternatively, you can run cross validation and see if the scores for each experiment seem close. If each experiment yields the same result, a single validation set is probably sufficient. Because every time if you are getting the same result, then you can say it's okay, it's fine, you don't need to do this. Okay. Now we'll work with some data. In previous tutorial we load in the input data sets. Let's see the Melbourne data set: rooms, distance, land size, building area, year built, and you have to use you have to predict the price. Exactly the same one. Random forest regressor, pipeline. In our last class we have studied about pipeline, and simple imputer to handle the missing values. Here see, pipeline has been created. First step is pre-processing. Pre-processing is done by simple imputer, missing values will be imputed. Okay. Second step, direct modeling. Here categorical variables, there is no categorical variables, so they have not bothered about that. In a pipeline they have pre-processed and they have using model. Model is the random forest regressor, these are the parameters. Okay. Now see, we obtain the cross validation scores with this function, cross underscore val underscore score. This is in scikit-learn function. So you are importing this one, cross underscore val underscore score. Okay. Now you have to set the number of folds. This is not fixed that you have to divide it into 5. You can use 3, you can use 4. It depends on your data set. Okay. So here they have used 5. CV means that the folding, how many number of folds you want to do. This is the parameter, CV parameter. Okay. Now see, they have used -1 into cross val score. They are sending the pipeline. X is the training data point, Y the output, CV equal to 5 and scoring equal to negative mean absolute error. Now why this negative mean absolute error? See, why we use mean absolute error, MAE? Why do we use that? To calculate the performance. How? By calculating the error. This is about mean absolute error. That means you are calculating the difference between the predicting data point and the real data point. So you are actually calculating the error. So our aim is that to keep the MAE low. If we keep the MAE low, that means the model is performing better. But see here, we are calculating scoring. So our job will be to make the score higher. Then only we can say that the model is performing better. So we have to keep MAE lower but score higher. Okay. So here what we are doing, instead of calculating mean absolute error, we are making it negative. So if we make it negative, then automatically this will become high. Exactly, we are reversing the process. Okay, because we want to keep it low but we want to keep it high, so we are just taking the negatives. Okay, now as it will give you the negative output, you have to again multiply it -1. Okay, now you can calculate the scores. If you don't calculate it with -1, these values will be negative. Okay, So now the scoring parameter chooses a measure of model quality to report. In this case, we choose negative mean absolute error. And okay, so it is a little surprising that we specify negative MAE. Scikit-learn has a convention where all matrices are defined, so a higher number is better. Right? Score should be higher. Higher means better. So using negative here means allows them to be consistent with that convention, though negative MAE is almost unheard of in elsewhere. Okay, so you understand in scikit-learn they are just following a consistency. Consistency of what? That score will be higher. The higher it is, the better it is. That is in scikit-learn. Okay. Now the problem is mean absolute error should be lower. So that is the reason we are making it negative so that it comes here as higher. Okay. You understand my point? And that's why we are multiplying it minus 1. Now you are printing the average mean absolute error. So using cross validation yields a much better measure of model quality with the added benefit of cleaning up our code. Okay, now let's do the exercise. For small data sets, cross validation is a great technique because your data points are fixed. So you just cannot separate as training data points and testing data points. So there it is better to use the cross validation techniques. Now let's run this. Pandas, train test split and sell price is the output. Okay. There are numerical columns. Fine. Now let's run this. It will take some time. Okay, so far you have learned how to build pipelines with scikit-learn. It's not done yet. Sorry, this is also not done. Okay. Okay. For instance, pipeline below will use simple imputer to replace missing values in the data before using random regressor to train a random forest model. We set the number of trees in random forest model with n estimated parameter and setting random state ensures reproducibility. See, the same thing. They have created a pipeline. First, they are treating the missing values. Then they are passing the model random forest regressor. Okay, so you have also learned how to use pipelines. Exactly. This code below use cross-val score function to calculate the mean absolute error averaged across 5 different folds. Okay, so you have to, you have to calculate the error from this one, 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 and then you are making an average of all of them. That is your job. Okay, now let's see. So you have to import cross val score. Now multiply by minus 1 cross val score, pass it through the pipeline. So the steps will be followed. It will be modeled. These are the data points and you are using 5. You can use any number and the scoring is negative mean absolute error. Okay, now you can print the scores. You have to run this one also. Sorry. Okay, now step 1. Write a useful function. In this exercise, you will use cross-validation to select parameters for a machine learning model. Begin by writing a function getScore that reports the average over the cross-validation folds MAE of a machine learning pipeline that uses the data in X and Y to create folds. Simple imputer with all the parameters left as default to replace the missing values. Random forest regressor, random state will be 0 to fit a random forest model. Okay, the n estimators parameters applied to get score is used when setting the number of trees in the random forest model. Okay, so they have already passing the n estimator, so you don't have to write like n estimators equals to something. They are passing it whenever they are calling the function. Okay, so your job is to replace this body. Okay, so first you have to do you have to take the xy. So I'll create the pipeline. My underscore pipeline equals to pipeline steps. What are the steps here? First one is preprocessor, right? Preprocessor is simple imputer. Okay, now the second step is model. So model Model is random forest regressor. Random forest regressor. Okay. Here number of estimators that is passed here, so you don't need to declare it here, and random state equals to 0. Okay, now let's run this. Pipeline steps, preprocessor, simple imputer, sorry, here starting this bracket. Okay, now calculate the scores. Score equals to -1 into cross underscore val underscore score. Here write my pipeline, pass the training data set, and output CV equals to any number you want to give. Scoring equals to, we are going to use negative, mean, absolute, error. Okay, so once this is done, you have to return the value. So return scores, and you have to return the average. Okay, average of all the folds. Okay, so let's say, sorry, scores. Maybe still, okay, sorry, it's written over here, retain the average MAE over 3 CV folds. Okay, that's okay. Now test different parameter values. Now you will use the function key that you defined in step 1 to evaluate the model performance. Okay, so corresponding to 8 different values for the number of trees in the random forest, for 50, for 100, for 150, 300, 350, 400. Okay, so for all of them you have to calculate these scores. Okay, so you just have to run a for loop and store your results in a dictionary. Okay, dictionary is the results, where results I is the average MAE returned by get score I. Okay, fine. So create a dictionary first. Fine. Now you have to create a loop. 50, 50 into 2, 50 into 3. So in this way it is going up to 400. So 50 into 8. So we can create a range of from 1 to 9, right? Now results, and here you have to write 50 into sorry, for I, 50 into I equals to, the function name is get underscore score. So you have to call the function and you have to pass 50 into I. See, for the first time 50 into 1, so 50. So it will be passed to n estimators as 50. So here it will be 50. Okay, so the number of estimator is 50 for the first time. Second iteration 50 into 2, 100. So you are passing 100. So it will be calculated for 100. Third loop 50 into 3, 150. So it will be passed as 150. Number of estimators will be 150. So you have to calculate for 150. Okay, and every time you calculate this, you are storing it in this dictionary. Perfect. Let's run this. So sorry. Okay, now if you want, you can check the output also. Let's see. Print results. Okay. Okay, now let's print the results. See, for 50 this is the score, for 100, for 150, for 200 this is stored in the dictionary. Okay, so use the next cell to visualize your result. See the graph. So matplotlib have been used. Results.keys are kept in x-axis. So these are plotted in x-axis, that is 50, 100, 150, and these are the values. So values are kept in a list and they are plotted in the y-axis. Okay. So you can easily say that for 50 this is the score, for 100 this is the score, for 150, for 200, for 250. Okay, the score is minimum, you can see from the graph. Okay, Now you have to find the best parameter value. So given the result, which value for n estimators seems best for random forest model? Okay, so for that you just can use min function or max function. So let's say I want to see results, comma, key equal to results dot get. So this will give you for which n estimator you are getting the, just let me print this, n estimators best. From the graph we can see the value 200. Okay, for maximum this is 100. If you write here max, then you can see that this is 100. Okay, so in this exercise, you have explored one method of choosing appropriate parameters in a machine learning model. If you would like to learn more about hyperoptimization, you are encouraged to start with grid search, which is a straightforward method for determining the best combination of parameters for a machine learning model. Thankfully, scikit-learn also contains a built-in function, grid search CV, that can make your grid search code very efficient. That is also kind of similar, grid search. Okay, in any class I will explain what is a grid search. Okay, if you like my videos, please subscribe to this channel. We'll meet in our next class where we will learn about gradient boosting. Okay, so meet in our next video. Till then, bye. Happy learning.